set up what we're going to see during the practical session. Okay. So my name is Jihad Ftouny. I'm a computer science graduate and an AI instructor at Zaka. And I will be enrolling in the master's program at USG. And on the side, I'm also a game developer and a web developer. Okay. So for the outline, we're going to go over a basic introduction to what are neural networks. And then we're going to go into the transformers architecture, which is what runs ChatGPT. And finally, we're going to see about the OpenAI API. So let's start by introducing the neural networks. Okay. So this session, we're just going to cover just the basics of everything we're going to be talking about here. It's just a foundational session so that you can get started with the API. So from biology to neuroscience, we know that our brains have billions of neurons that are connected together in trillions of connections. Okay. And these connections, they have different strengths, and that these strengths that these connections have between each other, they play different roles on how these neurons are going to fire information to one another. Okay. So to understand this complexity of the brain, we need to understand the most basic element, which is the neuron. Okay. So the neuron is a single biological neuron. It has dendrites, as you can see here. So the dendrites, they receive the signals from other neurons and the cell body to sum up all the information into the cell body. Okay. So we have, for example, the dendrites X1, X2, Xn. They receive the information from other neurons. The cell body is going to sum up this information. It's going to sum up this electricity. And then when this certain, there's going to be a threshold, a limit to how much energy it can hold. And it's going to fire to the next neuron. Okay. And basically, the synapses are what connects the neurons to each other. Okay, so this is the brain and how it works in a very simple explanation. Okay, however, to emulate this in computers, we created the artificial neuron. Okay, so this is like a mathematical or a visual representation, very simplified, of how the neuron is. Okay, so this is how these are the inputs. It receives here the inputs. And then it passes this information through the to the body of the neuron, which is calculated over the weighted sum, which is a formula, a mathematical formula. And then it passes to the activation function. This activation function is going to trigger if it's going to fire this information, this electricity, or not. In this case of information, in the computers, it's either a 0 or a 1, for example. Okay, and it can be any number between 0 and 1. So this is basically in very basic ways how the mathematical representation of neurons work. Okay, here we have a little bit more advanced way to see it. Here you can see the weighted sum, how it is represented. So it's basically the sum of the weight times the input that we receive plus a bias, and this bias we ourselves we set it. So like if we want to modify how this information is going to trigger whatever we're going to see in front of us. We set this specific bias in any way we want. So if we want to change the artificial network we're going to see in a bit, so this artificial neuron that we're working with, we can set a bias for it to have a certain tendency to give a certain answer, for example. Okay, so this is one of the information that we can pass to this artificial neuron. So now we know the basic of how neural networks work. Let's see some examples of architectures that exist. Okay. The first one that we have is the perceptron. Okay. It's a neural network defined by a single output neuron. Okay. So basically, we're going to have the many inputs that we have. It's going to calculate, and it has one output. Okay. So if it has one output, that means that it can only calculate either two classes, either 0 or 1. Okay, this is the perceptron. The information is still the same. It receives the inputs, like the input to the neuron, calculates it with the weighted sum alongside the bias, and then it's going to either trigger the activation function or not. Okay, so once it does that, it's going to trigger some information to the output neuron. To the output neuron, and this output neuron is going to tell us if what information it's going to give us. Okay. So one thing to note is that the perceptron can also only classify between linearly separable classes. So the weighted sum has to be a line. Okay. And it only calculates between two classes. That is, a single perceptron can only calculate between two classes. This is something important to know. Okay. Now, instead of just computing the output based on the inputs that we provided, we can add a layer between the inputs and the output layer. Okay. So you can see basically the perceptron over here, and then we have some other neurons on the back, and this is what we call the hidden layer. Okay. This is like many different hidden layers. Many different neurons that are interconnected by the input. Okay. So going on the forward now, we can see that we have the inputs here, and these inputs are going to pass the information to every neuron. And of course, you can modify this. You can maybe cut off this connection here, and this neuron doesn't receive this input. But basically, this is how it is. So you have this hidden layer, which is going to do different calculations. It's going to expand the ability of your neural network to calculate different things. Okay. And it's basically the same process. Each of these neurons are going to have their weighted bias calculation, their weighted sum calculation, their biases. Every single neuron has their own bias and weighted sum. Okay. And they all trigger a specific type of information, and some mathematics is going to do the work for you. Okay. Now, if we take a large number of artificial neurons and group them together, we get what we call a deep learning, a deep neural network. Okay. And this is where the name deep learning comes from, because it's a deep neural network. Okay. So the deeper, the more layers that you have, the more hidden layers that you have, the deeper your neural network is. Okay. So here, for example, we have the input units. We have the hidden layer 1, hidden layer 2, hidden layer 3, and the output units. Now you can see here that we have 3 outputs. Okay. This means that we can calculate beyond only 2 classes. So we can calculate, for example, I believe, I don't know exactly how many you're going to be able to do here, but it's actually a rather big number. So usually, when we have a network that has more than 2 hidden layers, this is what we refer to it as deep neural networks. So as long as it has 2 hidden layers, it's a deep neural network. Okay. So now we're going to go over the text data preparation. So when we are dealing with LLMs or ChatGPT, for example, ChatGPT doesn't take any text and works with it. It has to prepare this text and then work with it. Okay, so this is why we have to do something called text data preparation. So tokenization is something that we do during this preparation, which is a process of turning a string of characters from a sentence or from a piece of text into smaller tokens, or which is our smaller chunks of this text, smaller part of the text. So if you see here on the first one, we're actually using this sentence below here. Let's tokenize. Isn't this easy? Okay, this is the sentence that we are interested in. So if you want to tokenize it or separate it in smaller chunks, there are different ways that we can do this. Okay. The first one, it has a specific rule. We don't know what this rule is, but if you see here, like it's separating let and then apostrophe s is a different token, tokenize is a different token, exclamation is a different token. It's a very specific rule. If you see here, for example, n apostrophe t, what is this rule that's happening here? You know, so we don't really know what's the rule going on here, but it's doing its job. Okay. Later on, I'm going to see an interactive way to see those tokens. There is a website that you can use. I'm going to show you before we explain the tutorial. You can also tokenize by punctuation. So basically here, if you see, we are actually tokenizing every punctuation that happens. We are tokenizing our text. So here, when this punctuation happened, we separated, we tokenized it after it as well, and then the exclamation mark, the apostrophe, and so on. Okay. Now, this is also taken into consideration. No, it's actually not taken into consideration, the spaces. So if we tokenize into spaces, we are basically just tokenizing it into the space bar of the text, basically. That's it. After doing this text preparation, we do something called feature extraction. Okay. And we do this because the machine learning algorithms, or basically the deep learning algorithms, which is, if you don't know, deep learning is a subset of machine learning. The machine learning algorithms, they cannot deal with the data in this format, okay? And we need to convert this text that we got into vectors of features, okay? So basically, actual numerical vectors, okay? You have many different ways to do this. You have the bag of words, or the BOW, TF-IDF. Those two we're not going to cover. What we're going to see today is about word embedding, which is actually a way that we can use in ChatGPT to do different things, which we are going to cover in a bit, okay? So let's go into word embeddings, okay? So when dealing with word embeddings, um, basically what you are doing, you are calculating the words inside a 3D space, and the way that they are represented is a vector, as we mentioned. Now, how do we do this calculation? It's actually through the cosine similarity of these vectors, okay? I believe we have a question. Can anyone hear me? Please leave in the chat if you can hear me. Organizers, I cannot see the text chat from the participants. Can they hear me? Yes, they can hear me. Okay, good. Thank you. However, I cannot see the chat. I don't know if they have any questions. I'm not being able to see their responses.
The audience asking Q&A.
The audience what?
The audience asking the Q&A.
Okay, perfect. So, okay. So I'm actually going to show an interactive way for us to see these embeddings. I think it's going to make more sense of what's happening. So I'm going to stop sharing my screen. Or actually, I don't need to stop sharing my screen, actually. Okay. So here, oh, not this one. Let's see, other one. Let me Google it, actually. So this is the website. Organizer, can you please let me know if you can still see my screen?
What was the question again?
If you can see my screen still.
Yeah, I can see. I can see. But it's downloading, I guess.
Yes. Okay. Perfect. Thank you.
You're welcome.
So here is the so this is basically what we're seeing here is different representations of words through the vectors that we mentioned. And for example, if we pick a word here, let's pick a nice word. Analytic. Analytic is good. Or tracking. Okay. So I'll actually pick two equals. So here we can see the colored ones are the words that are close in resemblance in meaning to this word equals. Okay. Of course, this is going to happen after you train your neural network and everything. So the machine learning algorithm is going to learn these representations through the tokens that we feed it, and then it's going to give us the approximate, or the words that are very similar to it. For example, equals, proportional has a similarity to it. Fraction has some kind of similarity. Rate also, inequality, decrease. So these words are similar to the word equals, okay? So let me go back to the presentation.
Raise the hand. If you can answer here.
What was the question?
Just a minute. Open the mic.
I don't know if she's speaking. I cannot hear her. Okay. Yes. Go on, Sahar.
أيوة كنت بسأل sorry I know that using the deep learning means there is no feature extraction needed for deep learning methods. Is it right?
No, like you do need to do feature extraction. Yes. Basically, what you're doing is this word embedding, which is calculating the similarity of the words through mathematics, so through vectors. So this is how you calculate the similarity of the words through this tokenization. And after the tokenization, you do this feature extraction.
I know that the difference between classical machine learning algorithms and the deep learning algorithms is that deep learning algorithms don't need feature extraction. That's what I read about it.
Yes, it's a
okay.
similar process. It's a similar process to that. Maybe I shouldn't have used that term, yes, but I understand your point. Yeah.
Okay, thank you.
Welcome. Okay. So I'm going to go back to the presentation now. So this was a live interactive way to see it. Okay. So now the next thing that we'll discuss is how we can use neural networks to model sequential data. And what we mean by sequential data is that text is a form of sequential data because you cannot understand a text, a sentence, without hearing the previous words in that sentence, okay? So in a way, we need to do this in a sequential way, okay? So how we used to do it in the past was with recurrent neural networks, okay? We still use them, of course, for other use cases. We're going to see why we pick transformers to do what we're going to, why we pick transformers to use for ChatGPT, okay? So a recurrent neural network is a type of neural network that, again, is adapted to the sequential data, okay? So if we have data in a sequence such that we need a point to be understood before seeing another point in the future, we need some sort of memory that is going to allow us to get the information from the past, okay? So this is what RNNs introduced. So the main difference between recurrent neural networks and the classical artificial neural networks that we were discussing previously is that they generate something called a hidden state, as we can see here, okay, which is represented by letter A or in green. So this hidden state is what we call or think of as a memory for our network, okay? So what's going to happen here is something a little bit more different. So we have the input, and each one of these neurons, they have the input. So we start here at the point at the state x0. It takes the input, passes to this hidden state. This hidden state is going to do some calculations. It gives an output. And then this information that is calculated, it's going to pass on to the next neuron. Okay. So this is basically, and it goes on until the sequence is fully processed. Here we just have an animation of how this goes. So we can see here that we take, and then the hidden state is fed into itself. And it's just a smaller representation of what's going on here. So this information is passed here, back here, back here, and back here, and so on until the neural network finishes, okay? So this is what we call the memory. Now, finally, we get into the GPT's architecture, which is the transformers architecture, okay? And transformers, basically, they are a game-changing neural network design, which was introduced in the paper, Attention is All You Need. If you haven't read this paper, I highly recommend you to read it. It's publicly available. You can find it on Google. And it was basically tackled to some challenges that we had with RNNs, which are going to see in the next slide, okay? And it did this through something that we call the attention mechanism, okay? So we're going to discuss the attention mechanism in a bit, but first we need to see what are the limitations of RNNs. So RNNs, they are robust neural networks. They are not something very simple to, the calculations happening inside it are not very simple, but they do have some certain limitations, okay? And these were effectively overcome with the introduction of transformers. Some key points to consider when with these limitations. The first one being that RNNs would struggle with understanding and retaining context in a very long sequence of text. Okay, and it might forget some information from a distance point in that a distant past point in that sequence. Okay. Transformers, on the other hand, they excel at capturing these contexts in long sequences, okay, because of these attention mechanisms that we're going to discuss in a bit. And not only that, it also allows them to take into consideration any point in the sequence. So the way that we discussed here the RNNs earlier, you can see that it's a sequential way. So we start in the beginning of the sentence and we pass this information forward. Okay, this memory goes forward. However, in transformers, it has the capability to see the information that is after the text, okay, which was something that enabled us to create ChatGPT, for example. Also, RNNs, they lack the parallelism aspect of it. They don't have it because basically they cannot do two tasks at the same time. RNNs cannot do that. Transformers can do that, okay? Another point is that the exploding gradient and the vanishing gradient as well. These are two things that happen during the calculation of the neural network, mostly during the backpropagation. So what we discussed so far was the feed-forward aspect of it. So when we were discussing the neural networks, remember that we were going from the input to the output, okay? And the input receives, remember, the input receives the information, passes the information to the body of the neuron, and then gives an output, okay? But in the artificial neural networks, there's something called backpropagation, which is when it passes the information back to this neural network, which is going to update the weights and the biases of each of the neurons, okay? So this exploding gradient and the vanishing gradient, they are something that happen during this process, okay? The exploding gradient, actually, the exploding gradient, it occurs when the model's parameters that we're giving it, they grow exponentially to the point where it's going to be very unstable to train this neural network. You're going to have NaN values during this process, and it's going to make it impossible for the neural network to finish its calculations and give you a successful output. Okay, the vanishing gradient happens when the parameters that we were discussing, these parameters that are going to update on the backpropagation, when they go too low into how much they matter in this backpropagation step, and then it's basically not going to give a very useful output. Okay, it's not going to modify, and this happens mostly during the first layers of your neural network. Okay, so this is why it's going to affect the whole process going forward. So why do we pick transformers? Okay, the first thing is that they are explainable models to a certain extent. You've probably heard about explainable AI and how we don't know what happens behind the calculations of a machine learning algorithm, of a deep learning algorithm. But transformers give you a certain type of transparency of the calculations that it is doing, which we achieve with something called the attention maps. Okay. Now, these attention maps, if you see here, think of X as a word in a sentence. Okay. So these words, they're going to have connections to the remaining of the sentences. Okay. So if we calculate it, if we see here the attention map, we can see that the last word is very much related to the first word. Okay. So this is something that happened that enabled us to see how the calculations are done in a deep learning or a machine learning algorithm. Okay. They're also versatile. They allow you to they can be tailored actually to many different use cases. It can even nowadays it can even do images. It can do things with images, which was back then the transformers was exclusively for text, but now we can use it for image processing. And they're also very scalable, so you can scale them up, and it's going to improve the performance significantly. And they're also very efficient for parallel processing, or basically doing calculations simultaneously. So again, just as a quick slide here, we have the use cases or the applications that we can use transformers in, such as machine translation, speech recognition, text classification, image captioning, text generation, and object detection. All right. So let's now take a look at the attention mechanism. We're almost done with the theoretical part. This is the last section. And what is attention? Okay. So if we want to summarize a story, for example, we know which parts of the story that we should focus on. Okay. So in other words, what are the main elements of a story? Any story. So if I tell you, for example, the sentence, Karen is a nice person and she is very smart, you would automatically know that the word she that we have here is referring to Karen, okay? Because you are a human, you have been learning language since you were a kid, you know how to do these relations in language, okay? So in order to mimic this ability of our brains into the deep learning word, we use the attention mechanism, okay? So let's take a look at this example here. Let's take, for example, the word she, all right? From the sentence, Alice is wearing a jacket and she is freezing. The word she, for example, is very close in proximity to the words and the word is. But the relevance is weak because it doesn't have so much relation of the meaning of what is the meaning of this sentence, okay? But if you look at the most distant word from it, which is Alice, it actually has a strong relevance. And also the word freezing. The attention mechanism is what allowed us to do this distance relation and to understand meaning in very long very long sentences. Okay. So from this slide, I just want you to know that I don't want you to take a look at the architecture. We don't need to know it right now. We're going to discuss the encoders and decoders in a bit. But basically, it's that this process of looking into the different words in a sentence is called self-attention, okay? And the same sequence of words is called self-attention. This is the whole process that we were talking about, is self-attention. Attention is a general term for connecting the different sequences together, okay? Self-attention is looking into the sequence itself. Finally, we're going to look into the encoder-decoder architecture, which is the basically one of them is actually the architecture of GPT, not both of them. We're going to see why. And basically, in the transformers, we have this architecture here. So we have the encoder. The encoder is responsible for receiving input. Okay, it's going to create a representation of it, as we can see here in orange, and then it's going to pass this representation into the decoder. The decoder is going to receive this representation, and then it's also going to pass to receive some other inputs as well, not only the input from the encoder, and then the decoder is going to generate the output. So from this, you can guess that the architecture of ChatGPT, it is transformers, but ChatGPT is a decoder-only model, okay? Because it generates text. I know you give it input and all that, but ChatGPT as a structure, it's a decoder-only model because it already has the information and everything, and it only gives you the output, okay? Of course, I'm trying to keep everything here very high level because I believe many of you would not know the advanced stuff. But continuing with the decoder architecture, what allows us to generate text in the way that it does. So, for example, when you're using ChatGPT, when you ask for it to generate a prompt, you see it generating live the text. You see it generating word by word. And this happens because of something called triangle masking or masked self-attention, okay? And this basically self-attention, the concept that we were explaining before, self-attention allows the model to look into all of the words in the sequence. The masked self-attention only allows it to focus on the words that were generated previously. Okay, so this is why this is the strength of the decoder architecture. This is how it does things. So why do we have different architectures? Okay, now this is not a very accurate depiction of what's happening with the encoder and decoders. Now the ChatGPT here on the left, it's a decoder. And on the right, we have the BERT model, which was created by Google in 2018. which is an encoder-only model. So this model, for example, can do great things in the classification domain, for example. We have them as separate because they are specialized in doing certain things, okay? However, the decoder architecture and the encoder architecture as well, they are very powerful by themselves, but you can combine them together as well. For example, you have the T5 model also by Google. I believe it's by Google, which they actually use the encoder and the decoder architectures, okay, at the same time. But ChatGPT, you can see just the strength of how these separate architectures are, but by just looking at ChatGPT, which is a decoder-only model. Okay. So I'm going to take, sorry. Now we're going to look into the OpenAI API. Okay. So the OpenAI API, we're going to jump into the tutorial in a bit. We're going to go through Google Colab and how to actually use it. We're going to see some code, some techniques that we can do. But first, I want to just go over the things that we can do and some other stuff as well. So the OpenAI API basically allows you to use GPT through code, and in this way you can do different things like natural language generation, generating code, understanding language. You can generate images, you can edit images. Recently, you have something you can convert speech into text, which is one of the most recent models by OpenAI. It's available in different languages. You have in Python and Node.js, Java. Today, we're going to go over it with Python. And you can also have different models, which we're going to go over them in the next slides. Okay. So earlier, I mentioned that we have a live way, interactive way to see the tokenization process. Okay. So we have a website that we can access. And it's by Observable HQ. And here, for example, if you input some text here, for example, I am attending the DSC MENA. You can see the different tokens that that GPT generates. Okay, so this is the way that GPT tokenizes the information that it receives. Okay, so you can see that the number, the letter I. Now I think the text is a bit too small. Let me see if I can increase it. You actually have it available above here. So I am attending the DSC MENA. The word I is represented by the number 40. The word M by 716. Attending is this number over here. So this is how the tokenization process kind of happens, or basically how we can visualize the tokenization process. Something else you can do with this website as well, which is interesting. You can convert tokens to text. For example, if I put the number 83, 567, 236. Okay, it should generate. Okay, so it generated something that doesn't make a lot of sense. So let me put 40, 85, 6, 278. Okay, so starts making more sense. Of course, you're not going to convert tokens into text manually. This is the job of the computer. But basically, this is how the process happens. You also have this available on the platform by OpenAI, which is a very similar thing. And it actually has for both ChatGPT 3.5 and ChatGPT 4, and also for the legacy ChatGPT 3, which is no longer available for public use. You can actually use it with the API, but we're not going to cover that. But you can actually do that. And usually people who use it are just people who have legacy code and still have it available in the platform or something like that, which is something difficult to see nowadays. But here, for example, if I enter some text, I love computers, for example. You can see that it generated 3 tokens and 16 characters. Okay, so the reason that we actually print the amount of tokens that we have here, we're going to see in a bit, is because when you are dealing with your API, you have to know how to control the amount of tokens that you are going to generate, the amount of tokens that you want to receive from your users to avoid very high costs in your API. Okay. So let's go back to the presentation. Okay. Yeah. So now we're going to discuss one of the models that we have available for the API, which is the embeddings model. Okay. Now, the embeddings model, basically, you can do a lot of things with it. It's going to calculate the embeddings for you, and then you can do search. You can search results in a text base, in a text source of text. You can do clustering, where basically you are grouping a text by similar meaning or a similar query. You can do recommendations where you actually recommend a text that is similar to another. You can detect anomalies and many other things. You can do classification, and you can also do some different measurements of these texts so that you can analyze it in different ways. Okay, so these are some of the ideas that you have for the embeddings model. Now, for the fine-tuning, if you don't know what fine-tuning is when you customize a model or like ChatGPT with your own data. Okay, so it's going to allow you to get more out of the model by using this fine-tuning API in a very simple process. I'm going to show you both through code and both through the ChatGPT platform on how you can do this. All right. So this is going to allow you to get higher quality results. Maybe you want to customize ChatGPT to answer in a certain way. This is how you do it, through fine-tuning. Maybe you want to create a chatbot that answers in a specific way. You're going to do it through this way. It's going to allow the ability of the model to train on even more examples that maybe are not available on ChatGPT. Maybe you have your own set of data that you want to train ChatGPT on. It's going to save tokens because it's going to allow for shorter prompts. Maybe like you have an internal system for ChatGPT that you created for your company, and you want to save the amount of money being spent. You do it through fine-tuning. Okay, you train the model in a specific way so that you save how many tokens you are sending to the API. Okay, because this also costs money, and also allows for lower response time. Okay, so the process that we go through at a very high level, the first thing we do is we prepare and upload the data. We're going to see how to do this. We're going to train some of the models, and then you evaluate the results. And then you might have to repeat the process back to prepare and uploading the data. Okay, if your data wasn't good enough, you might have to rework with your data and then redo the process all over again. Okay. Finally, then you're going to use this fine-tuned model to save the costs that you are maybe facing. Okay. Something I want to note out as well is that the fine-tuning process can be as low as 10 data points. So when we see how to do it, I'm going to explain this further. We also have the vision model. We know that we have models that can generate image. You know that in ChatGPT, you have Dolly that you can also generate images. It's done through the vision model. And you can also use it through the API. Now we want to talk again a little bit about the costs, just to give you some general idea of how to use this API, okay, and how to save costs using the API. So maybe, for example, you are a developer and you have your own projects and you want to save costs as much as you can. Maybe you're still a student. Whatever your reason is, it's very important to save costs. The way you do this is by seeing how much each token costs for each of the models. Okay, so if you look here at ChatGPT for Turbo, the input is $10 per 1 million tokens. This is a lot of tokens. You can do a lot with this. But if you look at ChatGPT 3.5 Turbo, you'll see that 1 million tokens cost 0.5 or 50 cents. Okay, now how to pick between each other? Like when do you want to use ChatGPT 4? When do you want to use ChatGPT 3.5, for example? Okay, so what you're going to do is to decide, okay, do I need a very complex output from ChatGPT? If you don't need it, just go for ChatGPT 3.5. If you need, for example, to generate code with ChatGPT, I would suggest going for GPT-4, for example. Okay, so usually this is the way that you're going to decide which model to use. Okay, here you can also see the costs of fine-tuning your models, and basically it's the same idea. Here we have also the cost of some other different models. We have the embedding models. You can see that the embedding models cost 2 cents for every 1 million tokens. The audio models, so you have the text-to-speech models, which is the most recent development of OpenAI. And you also have here the cost of the image models, which usually takes into consideration the resolution of the images that you are generating. So you can see here that generating with DALL-E 3 in, let's take an HD, for example. If you're generating an image that is 1024 by 1024 and 1024, it costs 8 cents. And if you're going to generate maybe a little bit of a more larger image, it's going to cost 12 cents. Okay, so these are the kind of things that you want to consider. If you don't need a very complex output, just go for smaller models, more simpler models. We can actually see through the API, which you're going to see just in a bit, how to use or how to check for the total number of tokens that we want. So this is the output of the API, and you can see here that it actually gives you the number of tokens, and then you can actually calculate how much you're going to spend for that specific input. Okay, so this is something you can also do with API, because it's going to return you all the information regarding the prompt or from the user, the output, and so on. And here is just, I just wanted to talk a bit about the text-to-speech model, which is, I've talked a lot about it during the presentation, actually. And it's just that it's a text-to-speech model, which basically just transforms text into speech. And you have two different models. You have the normal one, and you have the HD one. Of course, the HD has better quality of the voice generated, and it's much more expensive, actually. So this is actually something that you can also do now with the OpenAI API. So finally now, we can actually start with the tutorial, and let's jump right away into it. Actually, I want to leave space for some questions right now, if possible, before I jump into the tutorial. Hello?
Can anyone have a question?
So no questions?
Okay, thank you, Jihad. It was very interesting.
Okay.
Thank you everyone for attending.
No, I'm
the
going.
talk.
I still have the tutorial to go through.
Okay.
Yeah. So it's going to be a technical. We're going to see a bit of code. Okay.
Okay.
Yeah. So let me open it here. Can I actually share it with the participants? I have a version that they can use themselves so that they have an idea of how to use it. So let me just make sure. Okay. So this is a version that you yourself can use it. I'm going to share it with you. I'm going to enable access after the presentation. So let me just do this. Okay. Okay, so we actually have some questions on the chat. So Sahar, does it mean I can enter my own data sets? Yes, you can enter ChatGPT uses its own data sets, but you can enter your own data sets to ChatGPT. I'm going to show you this in the hands-on we're going to do now. I think we'll ask a lot after this section. Okay, Ahmed, sure. Go on. Anyone see the questions here? Okay. So I sent a collab link on the chat, and I'm not sure if you have access to it right now, but after the presentation, I'm going to give you access. So let me start with the presentation, actually. Sorry, with the tutorial. So
Want to ask you?
I can't hear you very well.
Wissam, sponsor. Raise the hand.
Yes, I'm going to give access after the presentation because there's some private information in this I don't want to share right now. Mhm.
Okay.
Yes. So Omar has a question. Can we build our database and how? If yes, I'm going to show you now how to do it. Okay. So let me do that. So here we have a collab of how we can use the ChatGPT API. Okay. I believe most of you are going to be familiar with the ChatGPT, with the Google Colab, which is basically a cloud platform for us to explore different. You can basically just code on it and on a cloud platform. We basically just do some machine learning models, deep learning models on Google Colab. You have to connect over here, and I'm going to also just import some files over here. We're going to use them. So here I have my API key. I'm not going to share this API key because if I do, you can access my API key, my account, and so on. So I'm not going to share it. But in case you have the version ChatGPT 4, you can create your own API key. And this is basic. Actually, you can also, sorry, if you have the paid version of ChatGPT, you can ask for to have an API key so that you can use GPT through code, but GPT 4, GPT 3.5. You can use the vision models, embedding models. You can use all the models, but of course, you're going to have to pay to use these models. Okay, and this is why we were discussing about saving costs. So what you're going to do here, I'm just going to load the API key and pass it through a variable. And I'm passing it through this class here called OpenAI into a variable called client. Okay, so this is all we're doing here. And we're going to use this client when we are using the ChatGPT API. Okay. So there's something called the completions API, which is basically what we're going to be using here, which is basically going to allow us to create generate text through the API. Okay. So the first thing we do is call the client that we just generated, chat completions create. So this is how we create. So this is how we call the API. Okay. We pass the model that we want to use. Here in this case, I'm using 3.5 Turbo, which is the average model in terms of costs and capabilities. And here we have something that we have to pass the messages, which is also a parameter of this whole function. The messages, it's going to be an array and a list, and we have to pass to it something called the role. All right. So this role is going to define what we are giving to the API. Okay. So the first one is called system. Okay. System basically is the context. So basically, what is this? What is the model supposed to act as, for example? So here I'm passing it to be an expert cook of North American dishes. Okay. And then the role user, it's basically the prompt that we usually input into ChatGPT. So this is basically the way that you're going to be talking to the model over here. So if we print this, could take some time, depending, it doesn't, it's not something very fixed. Sure, taking some time. Okay, there you go. So here we can see that actually generated text just like in ChatGPT. Of course, when you're doing this in your local environment, for example, through VS Code or whatever platform you use, or the text editor you use, this is going to be, you can organize it in a better way. Here we're just giving a very brute example. But here, basically, this is how you use the OpenAI API in a very simple way. Okay. Something you can do as well is to force the LLM to respond with the JSON format. So we have a question. Let me see that. Oh. Okay, let me increase the screen then, if that's going to help. Okay. Okay. So we can also force the LLM to respond with the JSON format. So maybe because you need the JSON format to be output, you can do this through the API. Okay. So here you have the system, the content. So you are a helpful assistant designed to output JSON. Your task is to extract a specific information from user messages, including names, email addresses, and any other contact information from them. Also extract the main request, okay? So we're giving the model to do this, okay? And note that when you want to do this, when you want to do it in a JSON format, you have to pass the response format over here to be the type JSON object, but you also have to pass inside the prompt, inside the whatever part of the prompt you're giving it, to have it output as a JSON. If you don't, it might actually not work. So you have to both set the response format and the end inside the prompt that you want it to be in JSON format, the output to be in a JSON format, okay? So for example, here we have an example email, for example, hi there, I'm reaching out to inquire about the process of submitting my application for the developer workshop you mentioned. I've attached my resume and portfolio for review. Please let me know if there's anything else you need from me. Okay. Best, Jamie Smith, that's his phone number, and then the email. Okay. Here we can pass some different parameters. For example, you can pass the maximum number of tokens, which is going to help set the maximum number of tokens that you want the model to output. Okay. Note that sometimes it's going to overshoot, going to go a little bit higher than what you defined, but it does happen sometimes. Temperature is basically the creativity that the prompt is going to have. So the higher the number, I believe it's up to 1, the more creative this output is going to be. Since here we actually want something that's true information, we want it to be temperature 0. Okay. Here we are passing top P, which is basically just going to help us manage the creativity and the relevance. Just a variable that can do that. N1, here we are passing how many outputs we want. Okay, so you can actually output as many outputs as you want. For example, I'm going to set it to 2 over here. So this is going to give me 2 outputs. And we'll see in a bit how do we extract the two of these outputs. Okay. Stop none is just a parameter that you can pass. You can set to true if you want to end at a stop sequence, which is something that the ChatGPT is going to generate. And here the user ID. Okay. So let's do this. It's done. Okay. So now let's print the first output. And here we just pass 0 to this code. This is how we input the first output. Okay. So name, Jamie Smith, phone, email, request, all as a JSON format. Okay. If you want to extract the second output, though in this example, it's not really going to make a difference. But here you can also extract the second output that you generated. If I'm going to pass here, for example, number 2, it's going to give me an error. Okay. Because we only set the top, the number to be 2. So we have only 2 outputs, 0 and 1. It's a list. So this is basically how we do it. So let me just output again the first output. Okay. Now we want to leverage the API to create code. There's something, actually, I'm not going to go over this. There's no need. We all know how to generate code. Or let me do it. Yeah, why not? Here, you're just passing the create an API that can leverage a JSON response that contains name, phone, email, and request. It's going to be the same process that we just did before. It should take some time because it's generating code, and we're using the GPT-4 here, for example, to generate code. Okay. Since this is the best one for coding. Again, GPT-4 is the best one for coding. So here we can see the output of the code. And you can use, of course, this is a very simple code. You're going to edit it a lot. But it's basically boilerplate code that you can use. And here, something that we have to show as well, the usage of total tokens. Okay. So here we can see the number of tokens that we are using by accessing directly the total number of tokens that we use. So for this specific output, we used 235 tokens. Okay. So this is how you can access specific parts of your result from the API. We can also generate images. Here we pass client images generate, pass the model to be DALL-E 3. The prompt, we passed it, for example, a simple lion. This size, I'm setting it to be this size. Quality standard, I don't want to generate an HD image. And only one image. Here you can print as many images as you want. And then I'm also going to store the result with the response.data URL into this image URL. Okay, because it generates a URL that you can access the image from it. This does take some more time because it's generating images. And here we can print the URL of the image. I'm just going to copy paste this. And let me print it here. So here we have the image of a simple lion, for example. So this is how you generate image through the OpenAI API. Let's go back to the tutorial. Okay, something else we can do is prompt engineering. Okay, we all know about prompt engineering. I believe there was a session about prompt engineering. I'm not going to go too much into it. But basically, you can use this structure of the user of the system to generate better prompts and have better actions through the API. Basically, that's why we have a system role for this reason, to effectively do prompt engineering. I'm not going to run this here, but yeah. Again, you can use the Vision API, for example, to analyze images. Okay, just like you would in ChatGPT 4. So we run client chat completions create, GPT-4 Vision preview, messages, role user, content. Here's going to be a list. And here we're passing it to be, you are an expert data analyst. What can you tell me about this graph? And then we pass the image URL for the image. This is how we receive images through the API. And you pass this, which is basically this image that we have here. And I'm setting the maximum tokens to be 600 because for some reason this prompt generates a very high number, a very high number of tokens. So I had to limit it to a certain number. And I'm going to print it as well here. Okay. So we can see here, this graph titled Product Trends by Month is displaying the monthly trend comparisons amongst 3 types of products: desktops, laptops, and tablets. So if you go here, desktops, laptops, and tablets, over a 6-month period from January to June. Okay, so you can see that it can actually interpret images. It's been advancing very quickly, the capabilities of this model. So I highly encourage you to use it in your applications. Something very interesting that we have is function calling. Okay, so in function calling, you can actually call a function using the ChatGPT API. So it can access your code and call a specific function from your code and use that function. Okay, so for example, a use case for that would be to get the live weather, for example. So if you have an API, an external API that gets the weather, you can also actually use this function calling to call that API in a live way. Okay, so here we're going to give a very simple example using some simple mathematical functions. And we have, like, for example, some hard-coded functions as well. To get the product of 2 numbers, so number 1 and 2, this is a function. It returns the number 1 times number 2, and we have to return it as a string. Here we're getting the difference of 2 numbers, the sum of 2 numbers, and here the sum of 3 numbers. Okay, so I'm actually going to let me go over through the explanation. Actually, it's going to be better. Okay, it worked. So here we are defining the function list. Okay, so we need to define a list of the functions available in our code so that it can be accessed by the OpenAI API. Okay, so this here is the first function. Okay, the name of the function is get product of 2 numbers. So get product 2 numbers. The description, we have to give a description so that so that GPT can understand what does this function do. So get the product of 2 numbers. Okay, you pass some parameters to it, and here we pass, for example, a type object. We have to pass type object and the properties of that function, which is basically number 1 and number 2. Okay, it's a type integer. Type number 2 is also of type integer, and the description, it's the first number, for example, number 1. For number 2, it's the second number, for example, number 1. Okay, this is how we define. So we define the same thing for the remaining functions. Okay, and we also set here, forgot to mention that it has a required number 1 and number 2. So these parameters are necessary for you to call this function. Okay, we do the same for the remaining functions. So we're storing them into a list, a functions list. And then I'm also going to prepare here some prompts that I'm going to pass into ChatGPT. Sorry, into the API, into the OpenAI API. And basically, what is the product of 3 and 5? What is the sum of 3, 5, and 13? What is the sum of 1 and 2? Basically, the API is going to know which function to choose without explicitly coding it for it. Okay, of course, you're going to have these functions available somewhere, but basically, you can allow it to call these functions. This is basically the function calling. It allows the API to call the functions for you. This has a very high potential for developers, for example. So let's put it to the test, okay? So we have the prompts here, prompt 1, prompt 2, prompt 3, and prompt 4. I'm going to run it to save time. So what happened here? Name JSON is not defined. I believe I have an imported JSON. Yeah, well. I did not define the functions. Okay. So let me just rerun these just to make sure. Okay. Okay, so now it should work. And it worked. Okay. So here, what we're doing, we need to run a for loop that is going to go through the prompts that we're defining, because we're running 4 loops, 4 prompts. That's basically what we're doing. And the response, it's going to be also on the completions API. And the model is the GPT 3.5 Turbo. The content is going to be the sample of whatever we have. Yeah, so the sample is going to be the content of the prompts. And then we call the functions. We're setting the functions that we want to this function calling API to do through a variable that we defined earlier. And function call, we're setting it to be automatic. Okay. The response message, basically, we're just setting the output that it's going to give. And if the response message is a function call, we're going to do we're going to call it using the function call, calling through the name of that function. So basically this name over here. We're going to do some JSON to load the arguments of that function. And the available functions are these ones. So here we have the name of these functions. Okay. So we basically, here is where we connect our actual functions with the way that the API calls those functions. Okay. Function to call basically defines what function to call, and the response message it's going to return us what function to call. So I'm not going to go over it into much detail. We don't have too much time. But here, for example, you can see that the results were correct. So the prompt 1, what is the product of 3 and 5? So the API was able to call this function that we defined here and give us the output of that function. The second the second prompt was, what is the sum of 3, 5, and 13? Should be 21. It's 21. Okay. And this is basically the process. Okay. Something else that we can do as well, it's leveraging the embeddings to search for user reviews. And here we're going to use something called tick token, which is a library that allows us to use the tokens that it's generated by ChatGPT. And here is just a quick explanation that we already explained of the word embeddings, of how the relation of the woman, the relation of the words are with one another. So basically, man and woman are similar words. That's why they're connected. Queen and king are connected as well. And here we have the mathematical representation. We don't need to know that. But this is basically how it works. Here we call the text embedding small model. And okay, so we're setting an encoding to be of a CL 100K base. This is an embedding used by the GPT API. And here we're setting the maximum number of tokens, as simple as that. Here we have some data. So I'm going to show you this data. Okay. Okay, you cannot see let me reshare the screen then. Okay, you should be able to see VS Code now. Okay. So let me increase the size of the text. View appearance, zoom in. Okay, I believe that's going to be good enough. So this is some data that we're going to use. We're going to use this data to pass to the API, so that it can do a search on this data. Okay, so this basically is just a data set of reviews, and you can see, for example, here's some reviews. Okay. So the product does exactly as it should, and is quite affordable. It did not realize it was double screen until it arrived. So basically, you have many different reviews in this data set, and we're going to use the embeddings model to do some search. Okay. So we just passed this data set. It's already here in my Colab. We read it and everything. I'm just going to print it to make sure that it loaded correctly. And yes, we can see the reviews over here. Okay. So let's set the top end to be 200. So basically, I just want to subsample the 200 most recent reviews so that we don't feed too much data to this model right now, because it's going to do some costs. And then we drop the review time, which is basically an information that we don't need. Basically, just doing some pre-processing on the data. Okay. And we're also limiting reviews that are too long to embed. Okay, we're also doing that. So now we want to create a function that will get the embeddings of any text. Okay. So we run the function get embedding, and this is going to replace the text that we have here, maybe some artifacts that we don't want in the text, and then we are passing it into the embeddings model API, sorry, into the embeddings API to create it based on the input using the model that we defined earlier, and also that we are calling the embedding. Okay. So we can embed the full data and store it into a separate column as well. That's what we're going to do. And then we're going to print it to see what is the result of that. So this should take some time. So while it loads, what we're actually doing is transforming all this information, the embeddings, into a CSV file, okay? A new CSV file. So that's what we're going to be doing. It's going to be stored into a variable called musical instruments embeddings CSV, okay? So whatever embeddings the embeddings model is going to create for us, it's going to be stored into this CSV file. And here we are getting the embedding for the word hi. Let me actually print it here to see what was the result. Okay, so this is the embedding. You can see that it's a vector, as we mentioned, and it's a very complex to understand what is happening over here. But this is basically it. This is what we meant by embeddings. It's by a vector. This is basically how it's calculated. So using the API to do the search. So now we're going to finally do the search for our embeddings. Okay, so we have to manually set the cosine similarity function as a new update of the API. And this is basically just how you do the cosine similarity, and we're going to use this function later during the process of the search. Okay, so just as a point, again, this is important. You need to set the cosine similarity function yourself. Okay. So we're going to search through the reviews for a specific product right now. Okay. So let's say that we want to get the embedding of the description review that we're passing into this model, which is basically going to be the information that we're going to pass, that we want to search. This is the search that we wanted to do. Okay. Sorry. Okay. So we also pass the model. Here's the text embedding 3 small, DF similarity, so on. Like basically, we're just calculating the cosine similarity with this line of code here. The results we're going to call to sort the values by similarity, which is one of the parameters that this embedding API is going to return. We're setting the ascending to be false because we want the top similarity to be on top. Printing the head and the review text. Okay, so let's do that. So again, we are searching for the term guitar. Okay, in this huge data set that I just showed you here before, okay? So it's going to search the embeddings of this text, the numerical representations of this text, and then it's going to return us here, for example, the top 3, for example, because I define it to be n equals to 3. And this stand is sturdy, and my guitar, my guitar's seat like an anchor, for example. I use one of my electric and so on. Works great, does what it should, holds all my guitars securely. So you can see that it's actually searching the guitars, the texts that contain guitars inside them. Okay, so this is it for the embedding. And one last thing that we're going to do, which a lot of people asked actually, was how to use your own data to train the model, which is done through fine-tuning. Okay, I'm going to show you through the API. And if we still have time, because I want to leave some time for the questions as well, I'm going to show you how to do it through the UI in the OpenAI platform. So nothing through code. So I'm just going to show you through code right now. Okay. So what we're going to do is a mock-up of a chatbot that is fine-tuned, and it's going to help us. It's a chatbot that is responsible for creating material for an education platform, for example. Let's say that an education platform asks you to create a chatbot that is going to help them generate content for them, of course. So we do this. The first thing we have to do is to create a client files. So we basically, the first thing we have to do, remember, is that we have to load the data set. Okay. So just as a note, the model that we're using is GPT 3.5 Turbo for this example. And each model has a format to receive this data. Okay. So somebody has a question. Okay, Ahmed, can you see my screen now, by any chance? Okay, so I guess the image is clear. Yeah, okay, thanks. Okay, so the first thing we have to do is to load the data set, and we do this through the files create for the purpose of fine-tuning. Okay, here I'm passing the education assistant JSON file, which is a file that I already have here, and I'm going to show you how it is structured. Okay, so this is the exact format that your data should be in. Okay, and just as a note, I actually used ChatGPT to structure this for me, so you can actually use ChatGPT to make a proper data format for you. You don't have to do this manually. Okay, so just a quick information. So here we pass the messages, the role system, content, you are helpful extra. So this is my training data. Okay, the training data is basically when you're fine-tuning ChatGPT, you are fine-tuning it to give specific answers. Okay, so you have to provide it the prompt and also the output. Okay, so this is how we do fine-tuning for ChatGPT. You give it the input, but you also give it what it's supposed to output. Okay, and then it's going to train and give a specific output for that. So if you see here, you are a helpful expert content creator in the education field for a fully remote ed tech company. You suggest, sorry about that. Okay, so you suggest everything in a structured manner that is really easy to follow and implement. This is the system content. Sorry, the system role. Okay. For the user role, this is the prompt that we are giving the API. Okay, imagine as if you're using ChatGPT here. That's why I keep saying ChatGPT, because you're supposed to imagine as if you're using ChatGPT, but you're actually using the API. So I need to create a lesson plan on the water cycle for 5th graders. Okay, so this is basically the input or the prompt. The role assistant is basically the output that we wanted to give to us. Okay. So start with an introduction to the concept of the water cycle, highlight its stages, evaporation, condensation, precipitation, so on, so on. Now, what I want you to notice here is that I am fine-tuning this model to be a friendly assistant, okay? So what I'm fine-tuning it to do is here in the last sentence. If you need anything else, I'm here to assist. Query further to continue. Okay. If you require anything else, I'm happy to help. I'm happy to assist with further queries. So this is a very simple example of what you can do, but just for demonstration purposes, this is how you fine-tune the model. Okay, so me personally, I'm fine-tuning it to give these happy answers. Okay, and this is my data. So we feed it to the model in this way. So I'm going to do this. This is going to return you a JSON response. Sorry, an object response. And then what we have to do later is to use this file to fine-tune or to create a fine-tune job. Okay, so file, and this is the code that we want. We want to paste this over here. Okay, and this block line of code here, because we're going to create now the fine-tuning job, and it needs the input data. And we feed the input data, of course, through the API as well. So we just pass it over here, setting the model. Okay, I'm not going to do it again because this does take some time. I already run it beforehand, but this is technically what you're going to have to do. You're going to copy this here and paste it here. Okay, the file. You can check the state of the specific fine-tune jobs, for example, as well. So here is the fine-tuning job. So after you create the fine-tuning job, it's going to be creating and all that. Okay, so you can see the status of this job, if it was created, if there was any error, and so on. Okay, so this is the ID. It was created. So in this case, it was already created successfully. Okay, we can see that error, it had no errors, for example. The fine-tuned model is none, finished at none, hyperparameters, and so on, so on. Okay, so something else that we have to see here is the, let me find it over here. Let me actually just run this again. Okay, where is it? Here it is. So fine-tuned model, okay? This fine-tuned model parameter here, this is the one that you need to use to generate, to call the fine-tuned model, okay? So it's FT, GPT 3.5, Turbo, Zaka 9. This is the code, basically. This is all the information it has. So it's basically the model, the organization, and the ID of the model. You can cancel a fine-tuning job using this. You can list the top N fine-tuning jobs as well. So if you have different fine-tuning, you can list them differently. And okay, that's basically it. Now, remember that we already have the fine-tuning job here. You're going to pass it here, okay? This is basically how you do it. So I'm just going to run this already. And, or actually, yeah, let me copy the correct model. It's going to be better, just to make sure that we don't face any problems. Okay, or let me see actually. Okay, so it actually worked. So here we pass the system. This is basically how we're going to be calling the API later on. It's through this way. You are a helpful expert content creator in the education field. We set the content again. We have to pass the content when we're calling it because you're using the fine-tuning job. But in the user, sorry, in the system, you have to pass the system so that it understands properly what's going on. And then in the user, you pass whatever prompt you want. Okay. So can you help me design a quiz for a geography class about European countries? So create multiple choice questions focused on location of countries, so on, so on. So it's going to give you the information. And then in the end, if you see here, I'm here to support you if you need anything else. That means that my fine-tuning actually worked. Okay, so this is how you can make sure. So usually you're going to test it with one prompt, and then you're going to test it with more prompts and so on, more requests. Okay. One last thing we're going to see is the moderation, and with the moderation, you can actually see if anybody who is using your model, if they are actually requesting prompts that are inappropriate. Okay, so we're going to see the different considerations that the API considers as inappropriate. Okay, so we're just defining a function that is going to display the history of our chat. It's a Python code as normal. And here we are getting the assistant response. We're creating a function called get assistant response, giving it the messages that we're going to input, and returning the corresponding response. And here you can see that we're just passing the system, with the corresponding content, with the corresponding role for any number of messages. Okay, so this is also a Python code, but using the API. Here we're setting an empty array, moderation history also empty. We're going to use those variables in a bit. Here, for example, we are just emulating how ChatGPT works here. Okay, so this is basically, we're still using the same model that we were using before, but here, for example, if I want to create a quiz for my grade 9 students. Yep. So assistant to start compile a set of multiple choice and all that. Okay, so now I'm going to give it another prompt. So what is the capital of Egypt, for example? So we can see that this specific function that I created generates the full text. So what is the capital of Egypt? The capital of Egypt is Cairo. When teaching this fact to your students, so on, so on. Okay. So let's say now that I want to give it a prompt that could be inappropriate. For example, teach me how to. Of course, this is going to be inappropriate, but I'm sorry, but just for demonstration purposes, teach me how to kill someone. Okay. So here we can see, I'm sorry, but I cannot assist you with that request, okay? If you have any questions or need help and something else, feel free to ask, okay? But what do we want to get from this? What we are doing here, we are storing these responses or some aspect of this response into a variable called moderation output by basically getting the results of the moderation of that prompt, okay? So if I print here, I believe it's going to be more clear. And of course, it's not organized or anything, but here you can see the categories. For example, harassment was set to false for the first message. Harassment threatening set to false. Okay, but if you go to the last message, and I go here, so threatening false, here violence equals to true. So it actually flagged one of the appropriate characteristics of this message to be true. Okay. And it does this through the calculation of these numbers that you can see below. So this is basically how you use this moderation tool. Maybe, again, for example, for this education tool that you're going to be using with students, might be used with students, for example, you might want to use this moderation, okay? I know maybe I spoke too quickly. I hope the information was useful. Yes, I will share the Colab. And this is going to be it. So if anybody has any questions, please feel free to ask. So first, I'm going to go over the questions in the chat. Okay. So let's see. Sarah asked, okay, so all the ChatGPT API require payment. Yes. When you're using the API, back then you could use it for free, but right now you cannot. Every single API call that you're going to do does require you to pay. Okay, can you build our database? Can you build our database? And how? If yes, I already demonstrated that. Your head is blocking some of the code. Okay. Okay, noted. Guys, if you have questions, okay. If I want to use GPT with my trained data, what is better using? A trained model by coding, just like we did, or using assistant from OpenAI? It really depends on how customizable you want it to be. If you want it to be highly customizable, giving you certain aspects, I would say go for the API. And I would also go for the API if you want to use this call into other applications. This is basically the main aspect of why you would use the API. So basically, so that you can use it in other applications. I'm going to share the Colab, yes. What is the difference between using OpenAI API and LangChain framework? So the OpenAI API, you're going to use only the OpenAI API. That's basically it. The LangChain framework, the way it works is that you're going to be chaining different different agents together. And this is going to allow you to do different things. So basically, you have different AI agents doing different things, and you do this through the LangChain framework. How to train a model to make decisions based on knowledge from books. Basically, what you can do, you can maybe split the book into different prompts and into a single conversation. So remember here, if I open, let me share my screen again. Okay, so here, if you remember from the data that we fed the model, we set it to system role system, and then which is basically what the model is supposed to be, and then role user, and then you give it a role assistant. So you're basically emulating a conversation with the model. What you can do is emulate a conversation with the model using the information from the book. So you feed as much as you can to the model. For this case, I would suggest using ChatGPT 4 because you're going to be feeding a lot of text, and ChatGPT 4 does much better when you have a lot of information that you want it to be based on. I would do it this way, okay? So I would emulate a back and forth conversation of you feeding this information to the model, okay? So let me go back to the conversation. Okay. So if I want to train on a very large data in PDFs, how can I make this by coding? Also, will this affect my tokens use? You're going to have to use a different model. I don't remember exactly what the model is called to be able to load the PDFs. No, actually, what you have to do is to parse this information of the PDF into text file format. That's what you're going to have to do. Okay. It's as simple as that. You just have to parse the information to text and then feed it to the model. Any more questions? Also, will this affect my tokens use? It really depends on how much text, how much. Look, the token usage is based on how many tokens it generates and how long it takes to generate those tokens. Okay, so these are two aspects that you have to take into consideration when using the API. What is the price of just doing in-context learning, not fine-tuning training? Let's see. Let me share my screen. My screen is still sharing. Okay. Okay. So what is the price of just doing in-context learning, not fine-tuning training? Okay. So it really depends on the model that you're going to be using. So for example, if you're using GPT-4 Turbo, which is a cheaper version than ChatGPT 4, 1 million input tokens, it's going to cost you $10. Okay. For GPT 3.5 Turbo, it's going to cost you 50 cents for 1 million tokens. There is a calculator that you can use. ChatGPT token calculator. Price. So here, for example, you can actually calculate GPT for work, and then you just search pricing calculator. You can actually calculate how much it's going to cost. How to train a model to make decisions. Okay. What if the price? Okay. Do you recommend any book or online course to a very beginner on the topic? You mean specifically for the OpenAI API? Look, the thing is that for the OpenAI API, it's something rather new. You're not going to find much content online. It's difficult to find. When I was researching to develop this tutorial, I had to go through documentation and everything. I couldn't find it anywhere else. I had to go through the documentation to actually find some useful information. So I actually did not have some information to give you about that. Okay. I have tried to use Assistance API in my outside application, but it simply didn't work. However, it was working for normal chatting API, also Assistant. We're working normally with Zapier. Yes. I don't know exactly what you're facing, Ahmed, but yes, it does happen sometimes. It could be just a misconfiguration on the assistance API. Any more questions? Can the model be trained? Let me do this here. Can the model be trained on label information? How reliable is it? What do you mean by unlabeled information exactly? You mean like unsupervised learning? Yes, of course. I will share my LinkedIn. So Abdullah, do you mean I mean books, PDFs, articles? It really depends on what you're trying to do with this information. Now, the thing is, when you're fine-tuning the model, it already has the knowledge of GPT already. And if you're going to give it extra information, it's going to base its information based on GPT-4 with the extra information that you're feeding it, you know? So maybe GPT already has that information, maybe not. So it's really about testing. I cannot give you a specific answer, but it really depends on, you have to test it to figure it out how useful it's going to be for your use case. Do we need to configure callback functions on back end to use OpenAI API? Yes, you do. Let me share my LinkedIn. So here is my LinkedIn. Feel free to connect with me. I will accept you anytime. You can also contact me through my email. And yeah, well, I was does anybody have any more questions before we close? Yes, Nahel, I cannot give you any information regarding this because there isn't much reliable information online because the API is something rather new. And me personally, when I was learning to use this API, I actually went through the documentation to learn how to use it, which is something I suggest you doing as well as a developer, which is to learn through going through the documentation, okay? Because you learn much more faster. Did not get your email and LinkedIn. Yes, no problem. Here is my LinkedIn, and here is my email. Welcome. Any more questions? We still have, I think, 5 to 10 minutes. Okay, I guess that will be it. I hope you enjoyed. Thank you.
Thank you. Thank you, Jihad. It
Welcome.
was very interesting. And thank you everyone for attending the tutorial. We will have a short break now and see you back here at 4:30. Thank you, Jihad.
Welcome. Anytime.